So let's start with a story. Maybe some of my American colleagues can empathize with this story. Hopefully not as many people from elsewhere on the world, but probably do. This story occurs in April of 2021 in Oakland of California. After almost a year of isolation, COVID vaccines were finally becoming available for my age bracket. My health provider had emailed me a link. So I think to myself, okay, maybe I should sign up early. But this is my health provider, so they have my birthday. So no, that doesn't work. But maybe I should stay up late and sign up as soon as the bell tolls midnight. While the rest of California lies peacefully asleep, I can get an appointment. But then I think to myself, really, how bad could it be? So I decided to go to bed. Early the next morning, I dragged myself from slumber, blearily opened my computer and clicked through the link. And I see several appointments, some of which are convenient. So great, I select one. I see a form full of text boxes, a lot of text boxes, a lot of questions. So I very carefully spend some time to fill it out perfectly. And yay, great. Here's a bit of text, so great. I just need to click that I understand. And oh no, this time slot is unavailable. So I click back and wait a minute. Instead of seeing the I understand page or the form, I'm back at the landing page. And I think to myself, this is a single page app. Oh no. So I select another time slot. I click to an empty form, fill it all out again. It's a pretty long form. Doesn't work. So I go back, see different times, if I can actually click back and forth without errors. Sometimes I see the same times that I see before. So I make some coffee, tell my coworkers I'm gonna be late. And then I open a notepad and start filling out a bunch of text so that I can copy back and forth. So I can try to game the system, try to get from the first click to the last click in as few seconds as possible. So what is this story about? You know, I will admit I've written bad code in the course of my career. I've written software under incredible pressure with arbitrary deadlines, some might say stupid deadlines. I've taken down websites worth millions of dollars in monthly revenue. I've been on the operations teams of these same websites, keeping them alive while dozens of other engineers have competed to ship their month-long forks of code first so that the other teams would have to deal with the merge nightmares. We've been there. There's a couple of things that I've learned through this, and it's one of the primary things is that code is not for computers. Software is for people. Our decisions have consequences, and those consequences impact people. So let's look at some code that's actually written for a computer. I mean, what more do you need? I mean, you have the instruction set for every chip in your computer, right? And the instruction set's going to be identical for every chip, every computer that you're ever going to ship your code to. Everything is good. You know, there's a reason why over time we've moved further and further away from the computers that we write code for. There are reasons why one might need to write assembly, just as there are reasons why we might need to write code in a low-level language such as C. But, you know, things like this have risks. I don't know, this difference, I don't know if it actually caused seg faults for me before, or if it solved seg faults, but I do know that this library has called more seg faults on my computer in the last month than I've experienced in the last, you know, several years combined. Not to say that that's bad code, but it does have risks. The truth is that software is written for people. You know, code is written for our coworkers who might need to extend it tomorrow to support new features. It's also written for ourselves, where we might return in 6 months from now, you know, to debug a problem. If you haven't seen this keynote from RailsConf 2014 by Yehuda Katz, I highly recommend it. It's really great. I'll paraphrase it to say that we as humans have a finite amount of willpower that we're capable of exercising in a day, and decisions are cognitive load. There's only so much load that we can handle before we need to stop and take a break and rejuvenate. So the more times we have to ask questions like this, the less room we have to ask other sorts of questions that might actually be important. And the tools we use, the tools that we create, each come with a cost. But some of those tools have lower cost than others. You know, when Ruby on Rails was introduced, it was like gaining a superpower for me. You know, the opinions were incredibly helpful. In my experience, they were a little bit too focused on separating concerns for simple web pages and broke down when things got complicated, when applications grew in complexity. And after experiencing that pain enough, my coworkers started jumping to much more complicated patterns, first of all. But each of these came with a cost, which patterns to apply: form objects, presenters, observers, event buses, and like what library is cool this year. The library that we all knew and loved a year ago, no, that's old. There's a new one. Use this one. It works entirely differently. And I would like to say that Phoenix is wonderful. Ecto is wonderful. Opinions are helpful, but opinions are really helpful when they help you, when they don't get in the way. Phoenix, one of the reasons why I really love Phoenix is that it does separate web concerns from data modeling and functionally puts them in separate applications. And you can run multiple applications in the same VM. So it allows you to segment your code bases in ways that are really helpful. And we don't have giant buckets for models, for data models. You don't just say models. We have context, and we can understand that context emerge from the needs of the application. We can start simply. We can start by experimenting. We can start with a single file. And as the application grows, we can refactor to let the context emerge and to better build applications that we can understand. Live view is a superpower. Phoenix channels were a breakthrough. Long-lived states as long-lived processes on the server communicating over WebSockets, with all of the painful parts of distributed messaging abstracted away, and it just works. And it just works for a lot longer than what we might expect. Built on top of that, live view is a superpower, like React, but without React, without the pain of React, without fighting to get React installed, without having to sift through today's state management tool of choice to make React actually work. Opinions that actually help us to build tools. And Erlang and Elixir are full of these. Software with opinions, software that is simple to install, simple to get started with, but that scales to incredible load. And there are reasons why we can build more resilient systems with these tools, with simpler code. When I first heard the hype about functional programming and immutable state, frankly, I thought it sounded a little bit culty. Think of the garbage collector, I would say. I was fighting with the Ruby garbage collector a lot, actually, in those days. But here's some Ruby to demonstrate a problem that I faced over and over and over. It's oversimplified, but let's say I have an instance of a thing. It's a basket. And there's this really wonderful, super awesome library that someone wrote that solves a huge problem for me. But what happened to my basket? Like, why is my basket now a fraud? The fourth or fifth time I solved a problem that I caused for myself in this language, where I did this accidentally, especially when it turned out that other parts of our code base, depended on bugs like this. It's just one more ball that we need to juggle while we're juggling a lot of things at the same time to actually build a production-ready distributed system. And especially every time when we introduce new libraries, when I introduced new libraries, I would have to scour through the code, sometimes line by line, to see if it might be misbehaved. So there's something really nice about treating each function as a black box. The set of possible inputs can be tested, can be automated, have automated tests against the outputs. And if the function returns an altered thing, I need to specifically save off the thing in order to overwrite my older state. The tools help me to do the right thing. If we need to pick in that box, if we need to look at like how simple or stupid this might be, this is actually a pretty stupid function, but we can do so. If we need to refactor it to make the internals more complex, I think this actually is the stupidest thing that I could think of to actually implement the solution. But ostensibly, we can refactor it. When I'm outside of the black box, I can see the inputs and the outputs. When I'm inside of the black box, I can see the inputs, think about what is coming in, and make it work for that input to provide the next output without having to keep the entire context of all of the usages, every place this might be in my head at the same time. The wonderful thing about this is that it applies to concurrency and state. For me, Phoenix was a wonderful gateway drug to OTP. And now that I would say that the Erlang standard lib, particularly with the abstractions provided by Elixir, are the reason to choose Elixir. I've written this in a couple different languages. I've written event loops and event machines, and I've even helped to manage firmware before, where state was globally addressable memory, which was actually over a dozen pointers. And so state was the overlapping set of all of the different possible combinations of these pointers at any point of time, while it looped endlessly. And I would say that there's something so freeing about having a separate process with its own event loop. A message bus provided by the VM where every message is handled by a function that receives an input of the current state and returns the new state. It's freeing. We can reason about this, inputs and outputs. What happens when state is mutated by two different parts of the application at the same time? Turns out that can't happen. The VM protects us. Did your process receive multiple messages? Then what order were they received in? Because that's the order that they were handled. We can reason about this. And it turns out that the airline garbage collector is actually highly optimized for this, with each process having their own heap, garbage collection done concurrently. And yes, we can cause problems for ourselves when we need something more approaching the real-time part of soft real-time, but those problems are simpler to reason about. We can create buckets of code. And importantly, the tools that we use early in development are the same tools that we use at scale. We can model our problems in ways that actually allow us to ship our code faster, and then use the tools that Elixir and Erlang provide to distribute that code as the scale of our customers and our code base increases. One thing that I would say that for me is important to understand is that tools don't remove risk, but a well-built tools have understandable risk. If you are going to use a table saw has risks, but sometimes you might choose to use the slightly more risky table saw in order to build something, help us to build something better. Also, good, well-designed tools can be grown into. They might be simple to start using, but as you grow into them, you can use the tools to build larger, more important, more interesting things. And well-designed tools are a joy to use. Not to complain too much, I apologize if anyone at this conference helped to design that vaccine appointment tool that I used, but how could we have made that less frustrating? So thinking about the user, thinking about the human, first of all, what if we ask for personal info first? If we don't want to save protected health information into our database until the flow is complete, how about we put it into an encrypted cookie? Let the human do that work once so that the more complicated part, the scheduling, can be done later. What if we spun up a gen server whenever the individual selects a time slot, and we could even reserve a small number of slots for a short amount of time so that we know when the person clicks complete that time slot is still available. And this is live view. Hey, we have really well-built tools. So we can just show the person these reservation timeouts, short timeouts, incentivize them to complete the flow first. If it's something times out, we can immediately bump them back and show them a new list, rotate it through. And I know that this is overly simplistic, that there are a boatload of issues that would come up when actually developing this application for real. But the important part is that my teammates and I could have built this flow in a day. With the tools that our ecosystem provide for us, thinking about the user, thinking about the human actually using the system. And we could have spent all of the rest of the time before deploying, making it look pretty, working through edge cases, things like that, testing this with actual users, making it more resilient. So let me tell you another story. A few years ago, I joined a small startup in the role of CTO. I learned a lot in that half a year, especially questions that I should have asked before I joined. But on the first day, I was given GitHub access. I asked one of my new managees how to get started, and she gave me a worried look, explained that it had taken her over a month to get the project to run on her Mac. A month, I said, did no one help you? So she pointed me at the README, but as we looked over it, she would say, oh wait, no, we don't do that anymore. Oh, right. That didn't work for me. I did this other thing. You should email X. He has a database dump that actually works for development. He got it from production and modified it, so it's fine. Just download it from him. And in the first week, I fixed the database migration, successfully ran the test suite so that I could see the red test suite and start fixing the test suite. And when X reached out to me to see if I wanted his database dump, I explained that I deleted my development database every day. I just ran a script to develop to spin it up from scratch. And the point is not that any of these engineers were incapable or that I'm better, but the point is that I was empowered and they were not. And I expected our engineers to be empowered. How was I empowered? I was the CTO. My manager was a junior software engineer. To be honest, I'm a white male. She's a young woman of color. She had to navigate unspoken rules of the company culture, whereas the company really needed my experience more than I needed it. And most importantly, I really did believe that a new hire should be able to commit and push code on their first day. This might not always happen, but our workflows should make it possible. So onboarding someone into a new workflow presents a number of questions. And documentation is nice, but being able to run a script is better. So are my dependencies installed? Can my environment access required services? If I have a database, is that database actually set up, configured so that my runtime tools can actually access it? And in the past, I've worked on teams that have used tools such as like Chef Solo, Ansible, things like this, even, huge piles of custom bash scripts that would automatically run all of the steps needed to set up a development environment. But in the past couple of years, I've been working with a concept called Doctor, which was introduced to me by my current boss, Eric Hansen. Shout out to him. Doctor scripts have a set of checks that can be run, and these checks would not automatically change things. They check to see if something has already been set up. And if not, they suggest a remedy and put it into the paste buffer. So if you really can work with the default remediation, just run Doctor, hit paste, run Doctor, hit paste. If you want to solve the problem in another way, just make sure that you solve it such that the check passes next time, or a way to skip it for next time. So here's some examples of what the Doctor might check for. We've found a lot of success for this. What happens on the first day? Rather than going to a README, just run Doctor. Switch projects. What do? You just run Doctor. But other people might push changes to our projects, so we do need ways to update them. So having scripts that actually exec things, particularly execute things where there is no alternative remediation, like make sector migrate, things like this. It's really helpful to have scripts like this in every single project. How do we start the application? Docker compose, IEX, proc files. How about you tell me with a script? When I jump between projects, all I have to do is remember one thing. I don't have to always have to remember and read through the README and however that might be set up. So now that we can run it, how do we change it? Once again, how about you tell me, and not just through a bunch of documentation, but through something that I can execute. I can also audit my changes, mix format, check formatting, ESLint, Credo, Dialyzer, things like that. And I can ship my changes. Ship it really is, if these scripts are built correctly, or if these are, I should not say correctly, if these scripts are built robustly, ship it really can be the combination of, update, Doctor, audit, test, push. So now that we know that it works on my machine, are there any other consequences of what we just changed? I don't know what this image is. I was searching for art with or consequences. I think it's a 14th century monk poking a kid in the eye. Anyway, I loved it. Consequences. Each of these topics really is a long discussion, but if you can pay developers, you can afford to have a pre-production or a staging environment, and you can continuously deploy to it. So you are testing your deployment every commit. GitHub Actions are great. GitLab CI is great. So at this point, there really is no excuse not to continuously integrate tests. And if your CI is running your deployment to staging or to prod, then you have to have green tests and Credo and Dialyzer, et cetera, in order for you to deploy. Let your workflow guide you. so that you do the right thing, so that you have to do the right thing in order to actually ship your code. We talk about let it fail, let it explode, but that only actually works if you're capturing exceptions. But handily, there are tools, there are companies that will happily receive your money in order to do this for you. Not to say that you should use one or another, but Sentry and AppSignal are both really great tools that are affordable and simple to drop into a project. I would say that OpenTelemetry is in a little bit of an awkward place right now where it's almost 1.0. It's in release candidate phase, and even the release candidates have changed a bit between them, but it is the future. And so in my opinion, OpenTelemetry is the future, and everyone should just sign up for the free tier of Honeycomb. They're wonderful. You will want to pay them. I use the free tier and I was like, how do I pay you? You are amazing, Honeycomb. We wrap this up in a library, and not to say that you should use this library or that you have to use this library, but Elixir 112 made this a lot easier with mix.install, where you can install libraries without actually having to add them to mix.exs. Before 112, we did a lot of this in Bash, and then slowly migrated it to Elixir scripts that would run with mix run, and that was great, but mix install is better. And again, the important thing is not to use our library. The important thing is that our workflows should make our lives better, and that those workflows can be supported with scripts so that we don't have the cognitive overhead of having to do things differently on every single project and having to relearn the steps for each project as we jump between them on our workstations. If you're having luck with Docker Compose or Minikube, more power to you, but it might not hurt to have a Docker script that actually verifies that that tool actually works on your computer. That said, some tools just work better and teams can consolidate on using the same tools. So back to documentation for a second. Mixed docs was a really great, strong selling point for me for Elixir. But it's not just for module docs. Markdown files can serve as guides. So docs are great. What are the inputs and outputs of this function? Module docs, how do these functions fit together into a larger context? And guides, how do I actually get started? How do I configure? And how do I actually compose these modules, these functions, to make something that actually works? Module docs are not enough for a complicated project. Phoenix is really great about this. This is my go-to. Not only for the guides, but also what is the order of the modules to actually assist in understanding? Alphabetical is great, but if your deepest, most complicated module is the one that starts with A, alphabetical is not the right place to start. Good documentation takes time, but it saves you time. If you have an open source library, it saves the time of everyone who uses this. And importantly, it can tell you why was this written and why you might want to use someone else's library. Maybe your library does one thing really, really well and you don't want to support something else, but it's fine. This other library is great if you want to do that. Also, I would like to say that docs are not just for open source projects. Why add comments when we have module docs? We don't even have to compile them on a regular basis, but they're really, really quite useful. So YAML. No, just kidding. But kidding, not kidding. Infrastructure as code is a really wonderful thing, but YAML is not code. When I last worked at Pivotal, I worked on Cloud Foundry, and people jokingly had shirts that said Enterprise YAML Engineer. And I would think to myself, where is the future that I was promised? I don't think this is it. But there are other tools, and actually we can build tools that actually are more focused towards humans. Tools like Terraform, and more recently, my teammates and I at Geometer have been using a tool called Pulumi, which is actually infrastructure actually as code. Not necessarily all of the languages of your choice. I'm not sure that they have Elixir just yet. So we use TypeScript, but it has ifs and else's and everything that you might actually want. And I'd like to conclude by saying that computing does have real costs in the world. Our decisions might impact humanity in the long term in terms of carbon cost. When I was at Wanilo, we had a bunch of different applications: Rails, Sinatra, Sidekick, supported by Memcached, supported by Redis, with a lot of Redis. And the main application ran, I counted up recently, I think on 288 cores split across 14 servers. And that was probably the best optimized Rails application that I've ever seen before or since. But if this was Phoenix, that would have run on a handful of servers. It probably could have run on 2 or 3 servers, and we would have had more just for redundancy. And that would have reduced the need for other tools like Memcached and Redis. And we could have saved the company not only tens of thousands of dollars per month, but we could have reduced our carbon footprint to a fraction of what we generate. So that was a whirlwind tour. Here's a couple of places where I got the artwork for this. And if anyone is interested, here is the actual list of all of the artwork that I can, hopefully I got all of them. So thank you very much.
A round of applause for Eric Saxby for such a wonderful presentation, such wonderful slides. And we are running out of time, but there's no upcoming talk. So I think we have opportunity to make for the Q&A. So I wanted to go through the question that is posed, which is by our own language scavenger, Adolfo Neto. I'm not sure if you want to introduce yourself and make the question.
Yes. So I wrote that features of the language are important in the tooling, but what about the community? I mean, because I have interviewed some people when they said, oh, I really like the Elixir community because it's welcoming and people were nice. What's your opinion on how that adds to what you described in your talk?
I would say that it's extremely important. And the things that actually jump out at me in particular are conferences like this and the people involved in them. Actually, I would love to thank specifically Francesco, who's been extremely supportive over the years, and Barbara, who's really, really wonderful. But on top of that, like the framework supporters or the framework developers and the teams involved, and time and again, when I've had questions, the actual developers of frameworks have actually helped on the Elixir forums for me, as well as in Slack. Really, really, really wonderful. And again, not only supportive in terms of writing good documentation, writing really great tools, but actually individually, personally helping people who might be onboarding into this community. It's really fantastic.
Okay, thanks for the talk.
I do have a question. Is there enough time?
Yeah, go ahead.
Right, Eric, thank you for the talk. It was really great. I saw you mentioning about the scenario of jumping on a team with like lots of code already written and lots of people working in like some different ways and stuff, and tooling. I agree with you that tooling is very important, and it pretty much defines your capability of code output, if I can put it this way. But yeah, sometimes you find yourself in this scenario, like there is a lot of things that has been written. It's not exactly the best way possible, the best tools are not being written. So how do you introduce this culture into a team that is not like, because I think this is not exactly a technical issue. It seems to me, in my previous experience, that it's more like a human cultural issue into introducing this kind of tools and it shifts your way to think and stuff like that. So yeah, what are your thoughts about it?
Well, I'd say that it is definitely you know, an issue of like people, of humans, but again, I would actually start to say that that all of the software issues are really about people. So it's really important to actually dedicate time to it. It's kind of a challenging thing because when you onboard into a team that doesn't actually devote the time and the resources to things like this, it can be really challenging because sometimes it's kind of just sort of like butting your head against a wall, you know. And this is one of the things that I personally find really important when actually interviewing places, to really try to get at what their workflows are, what are the actual problems. You know, you can see the code and say, oh, maybe, you know, maybe the code is a little bit old or hasn't been as updated as often as you might like, or you know, is a little bit hard to understand. But it's the harder part is how do you actually change an organization to deal with issues like this. You know, I can say there's a lot of there's other tools that I would say that are important for actually maintaining a system like this, like actually caring about observability, and not only observability into the runtime, but into the business, you know, and into the development lifecycle. So at one job that I had, we had a dashboard. One of the dashboard blocks was, when was the last time we updated dependencies? And if it got older than a week, it would turn yellow. If it got older than 2 weeks, it would go red. And if that box was red, somebody had to actually spend time to do it. And the benefit of this was that we never had one of these huge issues where at a previous company that, oh gosh, what version of Rails were we on when I started? I don't remember, but we started pre Rails 3.0. And after I left the company, while I worked with at that company, an entire team was devoted to upgrading to 3.0. A year after I left, Rails 4 came out, and it still had not been upgraded to 3.0. These are the sorts of things that if you let it sit, it just causes so many problems for you. So you kind of need to amortize the cost of these things over time. So one little thing today is helpful, you know, whether that's, you know, adding a script to say, oh, hey, all of the things in the README, I just put into a script, now you can execute it. Maybe there's an existing tool that will actually help you to do that. Hopefully that medic that we wrote at Geometer will help with things like that. But if you do have bash scripts, to start to actually maybe move them so that there's a more consistent workflow throughout the different organization. I personally, I think one of the most important things in the workflow that I subscribe to is pair programming. Not everyone is willing or able or has a really great experience doing it. So I understand that it's not for everyone, but that's one of a really powerful tool for bringing someone on board. You know, you say, okay, here's a lot of code, rather than just say, okay, here's a bunch of readmes, ask me if you have any questions. You can not only say, cool, like here's the scripts, let me actually sit down with you and actually do this with you. Let's make sure that this gets onto your computer and actually runs. And as you find problems, not necessarily to say, okay, let's like, you know, it's been, you know, there might have been a certain amount of time between the last time this code base was installed from scratch on a computer to this new time. Let's actually put in the time to actually like fix this. And fix this in a way that is automated so that the next person, they're probably going to see a problem. If it's 6 months down the line, you know, the next version of the operating system is going to break your scripts without fail. But the next time you actually install it, you can actually fix those scripts. So now you're actively maintaining a system. You're not trying to change everything at once. So I would say like pick off a little thing. Start somewhere.
Yeah, interesting. It's very interesting to see that there is no magic around it. It's just pay the price every single day, keep fixing your tools and just keep doing every day. If I understood you correctly.
Yeah.
Thank you.
Yeah.
So there are a couple of questions, one by Samuel de Cleva. I will encourage everyone to, I'm sorry to interrupt, but I will encourage everyone to probably move at Toucan, so we can move the conversation over there and everyone can start like mingling with other people if they desire to. I also welcome everyone to give feedback to Eric Saxby for such a wonderful presentation. And thank you so much for everyone's time.
Cool. Thank you all so much. I'll jump over to Toucan, but I will go in and answer these questions in Huva as well later today.
Thank you so much, Eric.